used to call me on my cell phone. Late night when
Hello,
you
my name is Cadet Emerson Grimes, and today we're going to be going over the application of integration involving work. We're given the scenario of the construction of the famous Great Pyramid of King Khufu located in Egypt. Given the dimensions and the density of the materials, we want to calculate or estimate the amount of work done to build it.
So we're going to start out with our problem statement. So here we have our problem statement. So estimate the amount of work used to build King Khufu's pyramid. Now for assumptions. For this equation, we must assume that each stone is cut perfectly, considering it could affect the dimensions of the surface and the density, which are two vital parts of this problem.
So for our formulation of the equation, we have the height of the pyramid given to us at 481 feet, and we have the length of the pyramid given to us at 756 feet. In addition, we have the density of the stone, which is 150 pounds per foot cubed. So for our methodology, we first want to find the equation for the length of the pyramid. Using the slope, this gives us the volume equation. Now we want to solve for the force equation using page 455. Once we have the force equation, we want to plug that into the work equation, which is also found on page 455 in the Spencer. Finally, we then want to create the definite integral and evaluate it using mathematics. Moving on to the results, you see right here we have our slope equation. We use that slope to find the length, and then we find the volume. Once we find that volume, we come down here to our force equation. We multiply it by the density of the stone. Then we bring that over here to the work equation. So we have the force equation plugged into the work equation. And then we have it multiplied by the change in the height. So now we come down here and we create the integral. So we evaluate this integral from 0 to 481, which relates to the height of the pyramid. Once we evaluate that integral, we then come to our answer right here, which is 1.65 times 10 to the 12th power pounds per foot. As you can see, quality reps are very important. We have our assumptions right here listed, which pretty much shows us that this is a real-life equation. Then we have our formulation, which helps us to visualize what is going on. Then we have our methodology, which is used to explain what we're able to do and how we're going to solve this equation. Then we have our results right here, which pretty much shows our actions taken to solve this problem. My name is Cadet Emerson Grimes, and I approve this message.
And with that, I just have two more words to say. Obama out.
You used to call me on my cell phone. Late night when you need my love. Call me on my cell phone. Late night when you need